nitrate. Nitrate is an increasing problem, particularly in New Zealand and especially in the South Island. So what it is it's a compound made of 1 nitrogen and 3 oxygens. It comes from fertilizer or from sewage, and that means that it can indicate a pathway for disease-causing organisms or pathogens to get into our water supplies. It can have some really nasty effects on our health. So one of the things that it can cause is something called methemoglobinemia. Try saying that 3 times after a couple of lines. The English name for it is blue baby syndrome. So what happens? It's a very specific process, is that we swallow the nitrate, our stomach turns that into something called nitrite, which is a little bit different. That takes your red blood cells, the hemoglobin in those, which carries the oxygen to our muscles, and it turns it into something called methemoglobin. The long and the short of all those big words is that it means that your blood can no longer carry oxygen to your organs and muscles, which is a bit of a problem. As adults, we're really lucky. We have an enzyme which can convert that methemoglobin back into hemoglobin, or means that our blood can still carry oxygen and we can convert things back. Babies at under 6 months old don't have very much of that enzyme in their bodies yet. They're too young. And so what you can get is babies who are breathing, who've had access to a lot of nitrate-laden water, turning blue, and in some cases, unfortunately, dying. So it really is quite a serious thing. The other thing that nitrate can do at very high levels is that it may cause cancer. In this particular presentation, I've got that it may cause cancer at very high levels of 100 to 200 milligrams per litre, but there is some very new research that came out in 2019, which is showing that it might have links to bowel and colon cancer at much, much lower levels. Down at the, I'd probably have to look it up, but down at sort of 2 to 3 milligram, which is massive. It's a lot lower than anyone originally thought. So the maximum allowable value from the drinking water standards is based on that effect on children, that blue baby syndrome, and it's listed as 50 milligrams per litre. A bit of a trick for young players when you're reading water tests. 50 milligrams per litre when you measure the whole nitrate molecule, right? The whole nitrate molecule. The other way that some of the bigger labs measure it is they just measure the nitrogen part of that molecule. It doesn't weigh as much, so in consequence, when you measure nitrate as nitrogen, that maximum turns into 11.3. Okay, it's a direct conversion. So 11.3 times 4.4 gives you 50. It's a 4.4 conversion factor. So please, if you're not sure, don't worry about the numbers. Just look on the water test over it where it tells you what the maximum is, and they'll have the correct maximum as to how they've measured it on there for you. Luckily, we can get rid of nitrate, and there's a few different ways that we can do that. We can do it under bench, which is the more common way of doing it, and we can do it at a whole house or a whole industrial sort of level. Underbench is more common because people are mainly worried about what they're drinking. It doesn't really matter if you wash your hair or clothes in it. So we do have nitrate-specific ion exchange resins. We can put those in a softener type setup for the whole house. There's also little cartridges that you can get for under the bench. The most common way of doing it is an underbench reverse osmosis unit, which does a great job of taking it out. And it also doesn't fill up and then break through. The membranes will block up before you're going to get too much in the way of nitrate through. Finally, you can use distillation. Those little benchtop distillers do take it out. It's not recommended that you drink distilled water. As a general rule, it should be used for lab use, but it is a thing and some people have them, and if they ask, then yes, it can.